In this lesson, we're going to divide algebraic fractions, and it's important to remember the definition of division is that dividing by a number is the same as multiplying by its reciprocal. So that's what we're going to do. In this first problem, we're going to change the division to multiplication and change our divisor to its reciprocal, which of course, as you all know, means in this case, since it's written as a fraction, we reverse the numerator and the denominator. Now we have a multiplication of fractions problem. We mark out common factors. 3 and 33 are divisible by 3. A to the 5th and A to the 7th are divisible by A to the 5th. 11 and 22 are divisible by 11. And B and B squared are divisible by B. Be careful, look for what's left. I see a 2 times a B in the numerator and 11 times A squared in the denominator, and that's my quotient in lowest terms, so I write it, and it's time to move on to the next problem. A longer problem this time, and we're going to do it in a way that helps us show our work. We still have a lot of work to show, but it does cut back on the amount of space we need. We're going to mark a big X over the division symbol to change it to times, and then look at the 2 red curvy arrows on the right. What that means is that after we factor the numerator, we're going to write it as the denominator, and after we factor the denominator, we're going to write the factored form up in the numerator, and by doing that, that's the way we're going to write our reciprocal. So let's start the factoring. I like to start in the upper left, so I mark it out and write its factored replacement. And then in the lower left, I mark that out and write its factored replacement. And now I'm ready for the upper right, which is going to move to the lower right because of the reciprocal situation. I factor it and write it as shown. And finally, my final binomial that needs to be factored gets written in the upper right. But you may have noticed we have not yet factored completely, so we go back to the upper left. There's an a squared minus 16, a difference of squares, so we keep on going. Now that's factored completely. We go to the lower left, the denominator, and we see a trinomial which can be factored. Now it's factored completely. The upper right, what's now the numerator because of the reciprocal situation, the 3b times the quantity b plus 3, that can't be factored anymore. But we have a trinomial in the denominator that can be factored, so we factor it. Now there's a lot going on here. We need to be very careful. We start by canceling an a to the 3rd with an a, leaving us an a squared. And then we found a binomial, a plus 4 with a matching binomial in one of the denominators, also a plus 4. And then the entire 3b in the numerator can mark out the entire 3b in the other denominator, so we do that. And we keep on looking, and I see a b plus 3 and another b plus 3, one in a numerator, one in a denominator. I mark them out, and I'm still looking, but I don't see anything else, so I have a 4, an a squared, and a binomial of a minus 4 in the numerator, and a 3, a b plus 2, and an a minus 6 in the denominator. It's long, it's complicated. You have to be very careful that you don't leave anything out. And there it is, this division problem expressed as a quotient in lowest terms. And we'll do one more today. Same thing, it's long. We're going to make our X over the division symbol and mark our arrows so that we make sure we get the reciprocal in place in the right place. And we begin our factoring process by factoring out the greatest common monomial factor. We do it again and again, but this one we write in the denominator because it's a reciprocal, and yet again. So all 4 of our polynomials had greatest common monomial factors. And it looks like all 4 of them might have more factoring that can be done. So we do it up at the top. And that turned out to be a perfect square trinomial with both factors being a minus b. At the bottom, of course, a difference of squares. And in the top right, we have another difference of squares, only the first difference of squares was a squared minus 9, and this one was 9 minus a squared. And then we have one more trinomial, which is also a perfect square trinomial, only this one is b minus a times another b minus a. Now we have to be very careful. And we notice that we have a 2 on the top left numerator and a 6 on the bottom left denominator. So that fraction was not in lowest terms. Hard to know that at first, but after it's factored, you can tell it wasn't in lowest terms. So we cancel the 2 and the 6. They're both even numbers. And then we cancel the a and the a squared in the same fraction, leaving us an a in the denominator. And then in the other fraction, we noticed a 4a and a matching 4a, so those entire 4a's get crossed out. So neither fraction was in lowest terms, as it turns out. Then I see a pair of binomials that are opposites, the a minus 3 and the 3 minus a. So I mark them both out and replace one of them with a negative 1. A pair that match. Now they say a plus 3 and 3 plus a, but because of the commutative property, a plus 3 and 3 plus a are the same factor, so we mark them completely out. They are not opposites. But then we have a b and a b that I should have noticed before, but that's the way it goes. As long as you get it by the end, the b and the b, a pair of common monomial factors, one in the numerator, one in the denominator, we mark them out. And you might notice that the a minus b on the top has a b minus a on the bottom, so they're opposites. And there's another matching pair, another a minus b on the top, matches the other b minus a on the bottom, another pair of opposites. Notice on the top, all that's left are 3 negative 1s being multiplied together, which makes negative 1. And all I can see at the bottom is a 3a, so our final quotient is negative 1 over 3a. Dividing by a number is the same as multiplying by the number's reciprocal. When dividing a pair of algebraic fractions, change the division to multiplication and change the divisor to its reciprocal. Factor all of the numerators and denominators completely, then cross out factors in numerators that have matching factors in denominators. Finally, multiply all of the factors that remain in the numerators and denominators.